Hello students, welcome back to my channel. This is Harsh and today we will discuss miscellaneous exercise questions. So let's begin without wasting time. Our very first question is: the relation f is defined by fx equals to fx is defined by x square when x is greater than equal to 0 and less than equals to 3, and 3x, this is the function which is applied, and when x is greater than equal to 3 and less than equals to 10. The another function is gx. We need to show that gx is not a function and f is a function. Okay, so x square when value of x is greater than 0, greater than or equal to 0 and less than equal to 2. 3x when x is greater than equals to 2 and less than equals to 10. Okay, so what is the necessary condition to be a function? For to be a functions, a relation element does not have two images. Okay, let's have a look at the solution. Let's take first fx. Okay, let's put the value of f equals to 1. Fx, I'm not writing here fx because it's already written here. F of 1 equals to 1 because 1 square is 1, and when the numbers are lying from 0 to 3 we will use this function, and when the numbers are lying from 3 to 10 we will use this function. Okay, let's f of 1 equals to 1, f of 2 equals to 4, and f of 3 equals to 9, and the value of goes on rising. Okay, now let's take this function. F of 3 equals to 3 into 3 9. The same value is written here, so we need not to write one value again and again. F of 4 equals to 12. Okay, and the values end up till 10. Okay, from here we can say that these elements have distinct value. For example, 1 has 1, 2 has 4, 3 has 9, 4 has 12. There is no value which is repeated once again. There is no element which has two images. For example, 1 is 1, and if there were two images of 1, for example 1 4, like this, then this function would not be a function. Okay, now we can say that this is function because we can say this is function. Okay, let's have a look at this function. G of 1 equals to 1, g of 2 equals to 4, g of 3 equals to 9, and now the time came for this function. I regret for the mistake, but here 2 will come because the value of x is ending at 2 and the another function starting from the 3. G of 2 is 6 and g of 3 is 9, because see here, let me explain you once again. We have placed 1 on the place of x here, and we replace this x square with the 1 when this format is given here. This is the format which we need to apply here. When the values are from 0 to 2 we need to use this equation, and the values are from 2 to 10 we need to use this equation. Okay, and here we see that, well, there are two values of 2, there are two distinct of value, there are two distinct values of 2 which are 4 and 6, and therefore we can say that due to this value 2 has two images. That's why this is not function. Okay, not function, not a function. Okay, this was our first question, and let's look at second question. But before that, pause the video to note it down. Okay, students, let's look at our second question, which is, if fx equals to x square, fx equals to x square, find f of, find, we need to find out f of 1 into 1 minus f of 1 by f of 1 minus 1. This is a quite simple question and important question as well. Let's have a look at the solution. Okay, students, let's have a look at the solution, which is, we have given that fx is equal to x square, and we need to find out f of 1.1 minus f of 1 and f of 1.1 minus 1. Okay, let's take this function f of 1.1 square minus f of 1 square by f of 1.1 minus 1 square. Okay, do you know why I took the square here? Do you know why I took a square here? Because fx equals to x square is given here, and we have assumed the value of x here. We have assumed this value as x, and function is applied here as x square. That's why I took here f square. And what is 1.1 square? It is 1.21 minus 1 by 1.1 minus 1 equals to 0.1, and its square gives us, we have, after subtracting each and everything, we have 0.21 by 0.1. Okay, and now we have 2.1 as answer. Okay, this was a very quite simple question. What you need to do, what you need to just see this, what is given here, the function which is given here, and after that we need to find out this by replacing these values. Okay, now let's have a look at the third question, but before that, pause the video to note it down. Okay, students, let's have a look at the third question, which is fx, find the domain of function fx when fx equals to x square plus 2x plus 1, x square plus 2x plus 1 by x square minus 8x plus 12, x square minus 8x plus 12. This is the question which is given to us, and we need to find out domain of this question. Domain, I am writing here. Okay, let's have a look at the solution. We need to factorize this equation, and after factorizing we have, let me write down, fx equals to x square plus 2x plus 1 by x square minus 8x plus 1. After factorizing we have plus, it was 12, x square minus 8x plus 12. Here we will have x square minus 6x minus 2x plus 12, and after that, taking x common, we have x minus 6 minus 2x minus 6. So we have the solutions as x equals to 2 and x equals to 6. Okay, and the domain of this question will be r minus 2 6. The reason behind this is that if if we will put 2 or 6 in this equation, the equation will become 0 and it will the function will become not defined, which we don't want. Okay, so that's why we are subtracting 2 and 6 from the set of real numbers. Okay, this was the domain of this third question, and now let's talk about the fourth question. But before that, pause the video to note it down. Okay students, let's have a look at the fourth question. In this fourth question, we need to find the domain and range of the real function f defined by fx equals to under root x minus 1. Okay, domain and range. Domain, range. We need to find out domain and range. Okay, I'm writing here. Let's have a look at the solution. Let this equation fx equals to x minus 1 equals to 0, and domain of this question will be from 1 to infinity, and range will be from 0 to infinity, because if I put here 1, we will get 1 minus 1 0, which has under root as there is no under root of 0. That's why once from 1 till infinity, if I take here 2. Okay students, see here properly that if I, let's say I have taken x 1 for x, and 1 minus 1 equals to 0, and equals, we have our first input output as 0, and starting from this we'll get our output starting from 0 till positive infinity, and domain will start from the 1 and end till positive infinity. Do you know why I have not taken as 0? Because 0 minus 1 will become a complex number, which is iota. Okay, and you will come to know about iota in the 5th chapter of this class 11th math. Let's have a look at the 5th question, but before that, pause the video to note it down. Okay students, let's have a look at the 5th question. Our 5th question is find the domain and range of the real function f defined by fx equals to x minus 1. Fx equals to modulus of x minus 1. We need to find out domain and range. Domain and range. This is what we need to find out. Okay, let's have a look at the solution. Fx equals to modulus of x minus 1 equals to 0. Let this be equals to 0, and from here we see that the function we have given with that modulus of x minus 1. Domain of this function will be set of real numbers, because there is no restriction on this question, on this function. Let's say we have considered 1 for x. 1 minus 1 will give us 0, and what will output come? Output will come non-negative real number. Negative real number. The reason behind this is that if I took here 1 minus 1 will give me 0, and this is non-negative real number. And suppose I have taken here minus 1 here, minus 1 will give me minus 2, and modulus will neutralize the minus of the 2, and we'll have 2 here. Okay, that's why I have written here range will be non-negative real number. Let's have a look at the 6th question, but before that, pause the video to note it down. Okay students, and let's have a look at the 7th question. Students, I'm leaving the 6th question for you guys. If you have doubt, then watch the intro video of this miscellaneous exercise, and then you have still doubt, write in comment section. I'll reach you there. If it is necessary, then I will make another video to make you understand you guys. Okay, but now let's have a look at the 7th question. Let The question states that let f and g are the two functions defined from real numbers to real numbers respectively by fx equals to x plus 1 and gx equals to 2x minus 3. Fx equals to x plus 1 and gx equals to 2x minus 3. We need to find out f plus g, f minus g and f by g. F minus g and f by g. And so let's have a look at the solution. F plus g will be equals to x plus 1 plus 2x minus 3, x plus 1 plus 2x minus 3. From here we get 3x minus 2, and f minus z will be equal to x minus 1 minus 2x plus 3. Okay, from here we have minus x plus 2. Okay, and what is f by g? F by g is x plus 1 plus 1 by 2x minus 3. There is no need to go ahead and solve this question. You can simply leave this question here. Okay, and what I have done in these parts, I have just applied the simple algebra rules of these functions. Okay, and if you want to see the algebra rules, go to the intro video of this miscellaneous exercise or the 2.3 exercise. Okay, now let's have a look at the 10th or the 9th question, because 9th and 8th 9th question are very similar to the examples question. They have just changed the statement and everything is same in these questions. Now let's take the 10th question, which is very important. Okay, but before that, pause the video to note it down. Okay students, let's have a look at the 10th question of this exercise, which is very important. I'm marking this hash because this is very important. Let a equals to 1 2 3 4 1 2 3 4 and b equals to 1 5 9 11 15 16. 1 5 9 11 15 and 16, and the function f equals to 1 5 2 9 3 1 2 9 3 1 and 4 5 2 1 2 11 4 5 2 11. Okay, what we need to find out is f is we need to tell are the following parts are true or not. Our very first part is f is a relation from a to b. F is a relation from a to b. From a to b. Okay, let's see what is a and b set. A and b set are 1 2 3 4 and b set are 1 5 9 11 15 16. And if you see here, what is the function is defined from a set to b set such that elements are organized in a way such that the elements of a come here and the elements of b come here. I have already told you in this previous video of this chapter. Okay, now we need to see that is this relation or not. 1 is related to 5, 1 is related to 5, this is related to 5, and 2 is related to 9, 2 is related to 9, 3 related to 1, 3 is related to 1, and 4 is related to 5, and 2 is related to 11. This is a relation because in relation one element can have two images, but it is not a function because in a function no element can have two images. Yes, this is a relation. Our second part is f is a function from a to b. Now we need to state that this is true or not, whether the function is from a to b. Now we need to see that is this a function from a to b or not. No, this is not a function because 2 is having two distinct images, 2 9 and 2 11. 2 is having relation with 9 and 11 as well. Okay, we can simply write that no, this is not a function, not a function, because the element 2 is having two images. Okay, so friends, I'm not doing 11th and 12th question because in this exercise each and everything was very similar to the examples. That's why I have picked very questions of this exercise, and if you want to see that question, move to the exemplar video of this miscellaneous exercise. Okay, and if you have still doubt, I will make another video. Write me in comment sections. And thank you for watching this video, and if you like this video, please subscribe my channel and hit the like button. Thank you for watching the video.